Now, to adjust our app UI to different orientations, let's first of all take another look at this landscape mode UI. What's wrong with that here? Well, the problem is that this chart is too big and this list doesn't have enough space therefore. A better UI here would be to have the chart on the left and the list to the right, for example. And of course, that's just one possible way of improving the UI. Definitely feel free to use this as a practice opportunity to build different UI variations for different orientations. But here I want to indeed move the chart to the left and the list to the right. The question now just is, how do we do that without breaking portrait mode? Because of course here, in portrait mode, I want to keep the UI like this. I only want to adjust it if we're in landscape mode, or if we have that much width available, to be precise. On an iPad, for example, we also might want to have the layout on the left and the list on the right, even if it would be in portrait mode. So it's really the width I care about. If I have a lot of width available, having chart next to list might be preferable to having the chart above the list. So how can we adjust the code dynamically to the available space and update the UI if that space changes, for example, because the device was rotated? Well, for that we can go to expenses start, because that is in the end where I do output the chart and my list here. This main content in the end is the list if we have some list items. And therefore it's in the end here where we want to switch from a column to a row if we are in landscape mode, because that would ensure that items would be rendered next to each other instead of above each other. With a column they are rendered above each other, with a row they would be rendered next to each other. So therefore what we need to do here in this build method of expenses start is we need to find out how much width we have available. And if it's enough width, we want to switch from a column to a row. Now, to find out how much width we have available, we can use the media query class provided by Flutter. And you briefly saw media query towards the end of the previous course section. Media query has an auth constructor function, which wants the context object as input, since that holds important information, meta information to be precise, about the widget in which this code executes and its position in the overall widget tree. And once media query has been connected to context like this, you can access various pieces of information on that created media query object. For example, there is a size property which you can access. And this size property gives you access to a size object which holds more information about the available size on the device. For example, you can get the aspect ratio of the screen on which your app is running, but you can also get the height and width, and that simply is the available width and height on the device in which your app is running. So here, if I access width, for example, I get the width of my screen, and if I simply print this here so that we can take a look at that, and we maybe also print the height here, we can see that if I save this and I force a reload and we then open this debug console, that we see the width and height being output here. And of course, the exact numbers will depend on the device you're simulating this app on, but this here would be the width and height of the virtual device on which this app is running. Now, if I rotate this, you will see that it automatically prints new values here, which are the same values as before, just swapped. Because now the old height is the width and the old width is the height, because we switched from portrait to landscape mode. And since this gets printed again here, we also see that the build method seems to execute again if you rotate the device. And indeed, this is something Flutter does for you. It executes this build method again so that with the media query, you get the updated width and height so that you could adjust your UI that's returned by that build method, so the widget tree that's returned by that build method, to the available width and height. Therefore, now that we know that, we can store that width in a variable just to make working with it a bit easier. And now we could use that width to render a row instead of a column if we have enough width available. For this, we can use any of the conditional rendering approaches we learned about. For example, we can use a ternary expression. We can use this width variable, which I just created, this one here, down here in the body of this scaffold widget, and maybe check if width is smaller than 600, let's say. And if that's the case, we want to render a column so that we have the chart above the list. Because we don't have a lot of width available, hence having this vertical layout makes more sense. On the other hand, if the width is equal to 600 or greater than 600, we want to switch to a row instead. So we want to render a row here. And of course, the children of the row are the same as before for the column. So we can copy those children into the children list of the row. And with that, we switch from a column to the row depending on how much width we have available. Now there's just one thing we have to do, because right now this actually fails and we see nothing on the screen. Because one thing we have to adjust now is related to our chart. This chart widget in the end renders a container that has a width set to double infinity. Now I'll get back to what exactly the problem with that is. But in a nutshell, the problem is that with this width setting here, this container simply tries to take up as much width as it can get, only restricted by the parent widget in which this container, so in which this chart in the end, is included. The problem with the chart being inside of a row now is that the row also has a width of infinity, so it tries to get as much width as possible. And if you have a child that tries to get as much width as it can get, and you have a parent that tries to get as much width as it can get, you get an error because Flutter is not able to display a UI. To work around that, you should wrap the chart also in expanded, which is basically always the solution whenever you have widgets nested into each other that don't work together like this. And it should work. So if you save this and force a reload, you now see that indeed the chart sits next to the list. And with that, we now got a UI that makes way more sense, because now this UI works here on landscape, but it also works on portrait mode. And you see that as I switch between those modes, the UI gets updated and gets adjusted to the available width. And that's exactly what responsive design means. Your layouts adjust to the available sizes.